Hello friends, I've decided to record a few videos about our work. We carry out various types of electrical installation in residential and industrial buildings. Today's video is dedicated to the installation of a solar power system in a single-family home. I hope this video will help you if you're dreaming about having your own solar power system at home. And perhaps it will also save you from making some common mistakes. In any case, such installations must always be carried out by certified professionals. Don't hesitate to ask the installation company to show you their certificates so you can be sure they are properly registered and authorized. Let's begin. Every electrical installation starts with one important book. In Spain, this is the Low Voltage Electrotechnical Regulations. Your own country will certainly have a similar legal document which defines all the norms and rules that must be followed in any electrical installation. This book is essentially the electrician's Bible. The latest edition contains 53 instructions. We jokingly call them commandments, and the number grows with each edition. These commandments must never be broken. This is my personal copy of the book. It looks a bit worn, but it's important to me. I studied from it when preparing for my exams to become a certified, authorized low-voltage installer. All work on installing a solar power system must comply with the requirements of these regulations, and all components must be selected accordingly. And that is exactly what we do. Before installing any electrical equipment, we carefully read the corresponding installation manual. The correct functioning and reliability of the equipment directly depend on following the manufacturer's guidelines. Moreover, if the installation requirements are not met, the manufacturer has the right to refuse warranty service. The manual contains a lot of useful information: installation data, wiring diagrams, required cable cross-sections, characteristics of protective devices, and much more. We use this information when purchasing materials. We are installing a solar power system in a house with a three-phase electrical supply, so we are using a three-phase Huawei inverter with a capacity of 10 kilowatts. In front of you is the house's main distribution board, in Spain known as the Cuadro General de Mando y Protección. You can see that it is rather small for a three-phase home, which creates additional challenges because we need to fit a three-phase smart meter here. A smart meter is similar to an electricity meter. It is connected to the solar inverter via a communication cable and provides information on how much energy the house is consuming, or conversely, how much energy is being exported to the grid. This information is critical for the proper functioning of the solar power system. Later, we will also be installing a three-phase heat pump for heating the swimming pool, which will require an additional protective device in this same distribution board. So we need space for that as well. But of course, we did find space for the smart meter. However, there is one major problem. The smart meter kit includes 3 current transformers, CTs, one for each phase, which must be installed on the incoming supply cables that feed the house. Normally, we install these CTS inside the main distribution board, in front of the main automatic circuit breaker. But here, there is absolutely no space, and CTS are quite large. Fortunately, we found suitable space in the basement. The incoming cables are accessible there, and there is enough room. This is a junction box on the basement ceiling, located directly beneath the main distribution board. We've begun with the component that is both the heart and the brain of the entire system, the solar inverter. Solar panels generate DC electricity, which must be converted into AC electricity with the correct voltage and frequency for your household appliances. Excess energy must be used to charge the battery or exported to the grid, helping to reduce your electricity bill. In turn, The energy stored in the battery will be used at night or during cloudy weather. All these functions are handled by the inverter, and in reality, it can do much more than that. It is extremely important to follow the manufacturer's requirements and ensure sufficient clearance around the inverter, especially above it, at least 300 millimeters, and also below and to the sides. The device generates a lot of heat, which must dissipate properly. It must not be installed too close to the ceiling. Otherwise, it will overheat and may fail. For the same reason, the inverter should not be installed in very small rooms without proper ventilation. In this project, we're installing the inverter in the basement, but it may also be installed outdoors. If installed outdoors, the manufacturer recommends placing it under a roof or fitting a protective canopy to shield it from direct sunlight and rain. The inverter, solar panels, and battery must be protected with appropriate protective devices. We use DC fuses, DC circuit breakers, AC circuit breakers, RCDS, residual current devices, surge protection devices, SPDS. You can see two protection enclosures, one for DC protection and one for AC protection. Strictly speaking, neither the low voltage regulations nor the manufacturer's manuals require AC and DC components to be placed in separate enclosures. It would be enough to keep them separated by a divider inside one enclosure with correct labeling and electrical isolation. But our company's standards, and more importantly, our personal standards, are higher than the minimum requirements. Therefore, we install AC and DC protection in separate enclosures and label everything clearly. I mentioned earlier how important it is to ensure proper clearance around the inverter, especially above and below. In most of our projects, the battery is installed directly beneath the inverter. You may wonder why we didn't install the inverter lower, since there seems to be a lot of space between the inverter and the battery, which would have made our job easier. But we considered the possibility that the homeowner may later wish to expand their battery to the maximum, 3 modules. At the moment, only 2 are installed. When expanded, the battery will be taller. But thanks to our foresight, the clearance requirements will still be respected. Naturally, both the inverter and the battery are heavy, especially the battery, and must be securely mounted to the wall. All electrical and communication cables are connected using appropriate connectors and cable glands to ensure proper sealing. Regarding cables and protective devices, we use only certified, high-quality materials. Cutting corners here is never acceptable. Cables are installed inside appropriate conduits, both flexible and rigid, as well as trunking. Cables for the solar panels use insulation designed to withstand intense sunlight, so they can technically be installed directly on the roof. However, we never leave cables exposed on the surface. We always run them inside flexible or rigid conduits with good mechanical strength and UV resistance. This increases the lifetime of the installation and improves its appearance. We also bond all metal mounting structures to the building's earth connection, because saving money at the expense of safety is absolutely unacceptable. For mounting solar panels on different roof types, we use specially designed mounting structures. 1. They are intended specifically for solar panels. We never use generic metal profiles. 2. They are certified for solar installations. 3. They are built for long-term durability. 4. Their design and installation quality ensure proper wind resistance. You can see special concrete ballast blocks used on this flat roof installation. They help the structure withstand strong winds. We also use wind deflectors to reduce wind loading on the panels. Of course, pitched roofs require different mounting systems and technologies. Please also notice that the solar panels are divided into two independent strings, each connected to a separate MPPT input on the inverter. It is absolutely unacceptable to combine all panels into a single string simply to save on cables or labor. From all this, you can see our main competitive advantage. And no, it is not a low price. Our advantage is the high quality of the materials we use and the high quality of our workmanship. As a result, we hand over a solar power system that is ready for any inspection, even the strictest one. Finally, once all components are installed and all electrical and communication connections are complete, all that remains is to commission the system, connect the inverter to the internet, and configure its settings along with the battery. I won't bore you with the details. Our job is not finished until we install the dedicated monitoring app on the client's smartphone. In the app, they'll find plenty of useful information and can monitor their solar system in real time. After providing full instructions on how to use the system, we leave the client. Our job is finished. Almost. During the coming week, we will prepare all the necessary documentation and register the new solar installation with the authorities. Then the client, either by themselves or with our assistance, will visit their electricity supplier to choose the most suitable tariff for owners of domestic solar power systems. But the savings on electricity bills have already begun. Thank you for watching. Subscribe to the channel. I'll be back soon, before you even have time to miss me.